Hello everyone, welcome to JCE Connect. In today's presentation, I will be discussing on proportioning of materials by ROTHFUCH'S method. This method may be used when number of materials have to be mixed, number of maybe different types of aggregate samples you can say. These materials need to be mixed together for obtaining the desired or design gradation. A design gradation specifies the coarser aggregate, fine aggregate to certain percentages, but that is not possible from the source which is locally available for construction. From different sources we get different materials of different gradation, so that we have procured and mentioned as material A, material B and material C, and that is also plotted in the graph what we are seeing here. In this graph, material A, B, C gradations are there, that is plotted. On x-axis we have particle size in mm, and on y-axis percent passing from 0 to 100%, right? So that is with a given gradation that is plotted. The desired gradation may be decided either based on the recommended grain size distribution charts or tables or standard specifications. So as I mentioned earlier, on the graph paper we have with y-axis representing the percentage passing and x-axis representing the particle size. A diagonal line is drawn from a point corresponding to, say, the upper left, top left, that is 100% passing, that is maximum particle size of the material, maximum particle size of the material is, that is 2, and to the point corresponding to 0% passing, the smallest particle size of the material. The a different particle size marked on x-axis to the mean value of percentage finer than taken on y-axis. Now on this chart, the main grain size distribution curves of material to be mixed are plotted, which you can see material A, material B and material C as per their gradation. We have plotted the points and we have connected, so this gradation we are obtaining for material A, B and C, and this is our desired gradation from 100 to 0 mm, right? So now on the chart, the grain size distribution curves we have plotted uh, for different materials A, B and C, which are locally procured, right? And the balancing straight line of A, B and C are obtained, allowing only minimum of the area on either side of balancing lines. So there is balancing line. This, for example, for material A, what we are observing is this is a gradation line, and dotted line what we are seeing is a balancing straight line which is plotted for this particular material A gradation curve, so which need to be balanced for example on the upper side and the lower side, both we need to balance and plot from 100 to 0th, balancing both the things. Similarly for material B, this is actual gradation is this continuous line, but we are plotting on this dotted line which is a balancing line for that particular gradation, right? The opposite ends of the balancing straight lines of A and B are joined. Here you can see this is a balancing line for gradation A. Here it ends. for balancing line for material B is this. So what we are doing, we are joining the ends, two opposite ends of the two balancing lines for material A and B. These two are joined. Similarly between material B and C, so this line is joined. The points where these lines meet the desired gradation line, so these joining lines are meeting this desired gradation line at this particular point, at this particular point, and this at the zero. So as we have three materials at minimum of 2 points, this is going to cut the desired gradation line. One is between material A and B, that will be the percentage of material A which are mentioned on the right side of the graph, and similarly between material B and C it is cutting at the this gradation line, so that is remaining 29%, right? So this percentage from where you'll get from this is 100%, from this how much is this percent, and respectively those materials we can mention here. Similarly for material C is 13%. These values may be read, or you may get it from the y-axis by projecting the point of intersections. These point of intersections we are projecting on y-axis and getting the percentages 58, 29 and 13 for material A, B and C. What is this indicates? That is, if you take 58% of material A, 29% of material B and 13% of material C, if you mix, you will be getting the required gradation of mix. And it is not always necessary that the proportion of mix which is given, which is the maximum dry density, should also give the maximum stability, especially under the soaked conditions. Hence, it is also possible to design the proportions based on the stability test also, right? So this is all about the ROTHFUCH'S method, and we can discuss on the stability and index properties, right? So if you have any doubts, you can give a comment. Thank you very much.